New models and experiments are being constantly added to the NRP that prove the flexibility of the platform. We will show you 3 here.
Investigating swimming locomotion patterns has been a long-standing goal of the neurorobotics community. Here we present a simulation of a lamprey robot model that is swimming in the NRP. Under the hood, Gazebo runs a particle-based fluid simulation. The traveling wave that is generated by the controller enables the robot to swim forward, a behavior which is observed in animals and their robotic counterparts. With the NRP, we will further try to explain the neural circuits found in such animals, as well as to improve robotic controllers inspired by them.
In the Incar SNN project at Fortis, we researched spiking neural network-supported schedulability analysis. Such analysis can help scheduling new and unknown tasks and recovering from a soft or hardware failure in a car or robot. To be compact, energy efficient and fast, the spiking neural network is carried out by a neuromorphic hardware like the Spinnaker board. It currently predicts the degree of schedulability of a task set. To test its features, this and other NRP scenarios are used as a hardware-in-the-loop testbed.
In this experiment, we want to create a computer vision dataset that is recorded by a DVS camera mounted on an autonomous drone. We want to show that a DVS camera enables a faster reaction time than a frame-based camera.